We'll keep the eclipse going to the next key point, known as umbral point 2. As you can see, this is the point where the moon has completely entered the umbra, and this is the start of the total lunar eclipse. Now, interestingly, if we consider how the moon has moved from U1 and U2, and we take this point, the furthest point to the right of the moon, you can see that it's moved from here to here. Now you can see that the distance that the moon has moved is equal to the diameter of the moon. Now we can't put a ruler up in space to measure that, but we can use the time that it took to go from U1 to U2 as a proxy for the diameter of the moon. So if we were to note the time that these two events took place, and here we have a fictional time of 1746 for U1 and 1916 for U2, then the time in between these two times is equivalent to the diameter of the moon. Now, if we continue to follow the eclipse through to the next key point, which is when the moon is just about to leave the umbra, the end of the total lunar eclipse part, this is called U3 and took place at 22:27. Let's again consider the movement of the moon from where it was at U1. If we take the point furthest to the left of the moon this time, and then consider where it is during U3, you can see that it's travelled the equivalent distance of the diameter of the Earth's umbra. Now, assuming that the shadow of the Earth's umbra is the same as the diameter of the Earth, we've got a way of working out a proxy for the diameter of the Earth, and it will be the time that it took to go from U1 to U3. If we move this onto a timeline, it makes it easier to see the difference in scale of the diameter of the moon and the Earth. So we can work out the time it took to move to each of these points. From U1 to U2, the diameter of the moon, it took 90 minutes. That's the time from 1746 to 1916. And to go from U1 at 1746 to U3 at 22:27, it took 281 minutes. Using a little bit of maths, we can divide the time the moon took to travel the diameter of the Earth and divide this by the time it took to travel the diameter of the moon, and we can see that the Earth's diameter is approximately 3.12 times larger than the moon's. Now, back in around 250 BC, Aristarchus of Samos had this realization, and he also had an approximate value for the diameter of the Earth. So presuming that Aristarchus believed the Earth to have a diameter of approximately 13,000 kilometers, he could take this a bit further and work out the diameter of the moon. Using some simple ratios, you can see that you need to multiply the minutes by about 46 to get to 13,000 kilometers. And doing the same on the other side gives you an approximate value for the diameter of the moon of around about 4,164 kilometers. Now, Aristarchus's measurement of the circumference of the Earth and the diameter of the Earth, therefore, was a little out, which led to some inaccuracies in the measurements, but it was some impressive maths to work this out. Going back to our lunar eclipse, there's a final point, the point where the moon leaves the Earth's umbra, and this is called U4. As you may be able to see, you don't just have to use the points that we used in our calculations. The distance from U1 to U2 is the same as U3 to U4, and therefore they're both good approximations for the diameter of the moon. And additionally, the time from U1 to U3 is the equivalent of the time travel from U2 to U4. So again, these could be used interchangeably. So there you go. Using a lunar eclipse and a watch, you can work out the relative diameter of the moon compared to the Earth and follow in the footsteps of Aristarchus. Now, there are a few assumptions that Aristarchus was working with, And these are that the moon travels at a constant speed through the Earth's umbra. It doesn't speed up or slow down. He also assumed that the sun was so far away that the rays were parallel when reaching the Earth. And this was important as it would mean that the shadow cast, the umbra, would have the same diameter as that of the Earth. And lastly, that the moon's path would take it through the centre of the Earth's umbra, which had the same diameter as that of the Earth. So now you know how to work out the relative diameter of the moon. Have a go at our quiz questions and see how well you can do.